Professor Hubbard. I am working on the midterm right now. Um, it is me, Gabriel, working alone on my midterm. Um, okay, I'm gonna do number 6 for you, but I'm just gonna flip the camera and show you kind of where I'm at so far. Okay. So, just looking at number 6. Um, I'm gonna use because we're given half-life, I'm thinking, okay, let me just use some of the stuff that I know. So use the and it says use the radioactive decay model. And we're also given that tau, which is helpful. So the things that I know, it's going to be a little hard to write and record at the same time, but the things that I know is that we're going to be using this model. I think if we solve for K, we should be able to then plug in that K into tau over here. So let's do that. Let me see if I have like a stand or something. Okay, whatever, I'm just gonna hold it. Okay, so at time 0, we're giving an initial sample that has 500 Gs. Okay, how long will it take for there to only be 150 grams left? So at time question mark, we need 150 grams. Says that if it happens before I retire in 40 years, then I should keep the sample, otherwise I'll give it back to her. Okay, so is T greater than 40 years? The professor also asks. We don't know. Okay. Cool. That's what I got. We also know that the half-life is, so this tau is equal to 21.77 years. So we know that that in 21 point, so if we have another time of 21.77, this should be 250 grams theoretically. Okay. And so let's do stuff with that. Let's think about this. So let's try this. Okay. Let's try the points. Let's just try the points that were given. So let's just try 250 grams. 250 equals A naught is 500. 500 grams. K, the time is 21.77. Let's just simplify. So we get 250 over 500, so we just get 0.5 equals EK 21.77, right? And then what we're gonna do is take the natural log of both sides. So ln, just using this. Let me like put this on my laptop or something. Like, I'm just gonna like put it down or flee me. This sucks. Okay. Ln of 0.5 gives us negative 0.693 stuff equals, and that right there. And so that right there, this right here is going to cancel. So we get k to the 21.77. And then we're just going to divide. Okay, just divided that side by that. This is what we get for k, which is, so now let's just plug in. Well, actually, tau doesn't have any. Tau doesn't have anything that'll help us get the t. Actually, so solving for k was kind of futile. Given, well, I guess there could have been just like a much simpler way to solve for k just using this. Oh, but that's basically what I did. The ln of 0.5. Yeah. Damn, I just did a more complicated way of doing that up there. Wasted my time. Okay, whatever. Well, that's cool, because what we can do now is we can just plug in things that we already know. So okay, so here, so we want to know when it's going to be 150 G's. 150 equals a naught is 500 e to the this, right? This is 0.0318. Time is equal to question mark. Solve for time. Let's do that right now. I'm gonna get a tripod or something. Okay, 150 divided by 500. So 0.3 equals e to the 0.0318 t. All right, let's just natural log it, and we'll get our t's. ln of second answer. Dude, what the hell is second answer? Okay, get that is equal to what is that? Negative 1.204 is equal to, taking the ln of this right here just cancels it out to where it's 0.0318 t, and this is also negative because time, well, because we solved and found that it was negative, and we know that the result is going to be time, which is positive. Time can't be negative unless you're getting theoretical and stuff like that. So let's divide this answer right here by 0.0318. Just pretend that negative isn't there because it's, I didn't divide it by a negative number. Equals roughly 30. So let's just say it's just 38 years almost. 38 years, right? That's that 37.86. Yeah, that's about 38 years. That makes sense. That makes sense because 38 years is greater than 21 years. And at 21 years, you get 250 grams. So it's going to take about 38 years to get to 150 grams. That makes sense. Is t greater than 40 years? No, it is not. You're keeping the thing that your mom gave you. You're keeping the chemical or whatever. The answer is 38. Well, it's 37.8. 37.9. Okay, cool. So yeah, that's the answer.